this figure we will be calculating once again, because there is some small issue here. So if I take these two things, first let us calculate this thing. So 0.4 into 8.314, that divided by 28. So this figure is coming to 0.11877 plus this thing 8.314 divided by 28.9. So that is we are getting 0.287. So this is the uh, numerator, and then divided by 1.4 as it is. So if you do this calculation now, 0.11877 plus 0.2879, so that divided by 0.4, 1.4 divided by 1.4. So you are getting about 0.290 kilojoules per kg. So this is the gas constant for the combined the total. So including carbon monoxide and air. So now we will substitute this thing in here to calculate the P. The pressure of the total mixture, pressure of the mixture is equal to M. What is the MRP by V? So what is M here? 1.4. And R is equal to, we got the R as 0.290, and T is the temperature, that is 293, divided by volume. What is the volume here? 0.35. So here by calculating this thing, 1.4 into 0.290 into 293, that whole thing divided by 0.35. So you will get about 339.88, approximately 340 kilonewtons per meter square. So this is the combined pressure of this mixture. So now our next step is to calculate the partial pressures. So to calculate the partial pressures, first thing is we need to know the mole fractions. So let me write the example. Partial pressure of CO is equal to the number of mole fraction. So that is N of CO into the mixture pressure. So here NCO is the number of moles of the particular gas in the whole combination. So how do you get it? This NCO is equal to what is the mass of this carbon monoxide is 0.4 divided by 28 is the molecular weight, plus what is the so that divided by the sum of these two things, that is 0.4 divided by 28 plus 1.1 is the mass of air, 1 divided by the molecular weight of air. So this will be giving the fraction of carbon monoxide molecules in the whole mixture. So how to calculate that is, so you will get it 0.4 divided by 28, that is the numerator. So numerator is coming 0.01429, that divided by, you are going to get by calculating this thing once again. So the denominator 0.1429 plus 1 by this part, so 1 divided by 28.9. So that is your 0.0346. So this is your complete the part of carbon monoxide in the mixture. So if you calculate that, so you are getting the numerator. So this is the denominator 0.0489, and numerator is as it is 0.01429. So that is you are getting. So if I divide these two things, 0.1429 divided by 0.0489, so that is about 29.2% is the mole fraction of this particular thing. So actually the answer is coming like 20.292. So this is the mole fraction of your carbon monoxide. So if you substitute that here, 0.292 into the full pressure of this mixture is 340. So you will get it about, so the partial pressure is about 99.36 kilonewton per meter square. So this is the partial pressure of the carbon monoxide in the whole mixture. So similarly, we can calculate the partial pressure of uh, air in the whole mixture. So in order to do that, again we have to find out the the mole fraction of air in the mixture. So for that we can calculate this way: mole fraction of air is equal to n of air is equal to the number of moles of air, that is, one is the mass of this air in the, and molecular weight is 28.9. Same thing, the denominator will be same. So the 0.4 into 28 divided by 28 plus 1/28.9. So that your, so the denominator will become same thing, that is 0.0489, and the numerator is changing here. So 1 divided by 28.9, so that is 0.0346. So that you will get 0.0489. So it is coming to about 0.708. So this is the mole fraction of air in the mixture. So now we have, so if you want to cross check, so if you add up this NCO and N of air, so you will get, that is, here it is 0.292 plus these two, if you add it up, it will come to 1.00. That means, so that is, the answer is correct. Now let's go back to the calculation of partial pressure of air. That is, partial pressure of air is equal to mole fraction of air into the mixture of the pressure of the mixture. So that is, what is the mole fraction? 0.708 into pressure of the mixture is, we already have 340. So in this case it is going to be 0.708 into 340. So that is about 240.7 kilonewtons per meter square. So this is the partial pressure of air. So if you add these two things, you have to get again 340. So the total pressure of the mixture is equal to partial pressure of carbon monoxide plus partial pressure of air. So which is here, we have the answer is, partial pressure of carbon monoxide is 99.36 plus the partial pressure of air is equal to 240. So if you add these two things, again you will get the answer 340. So roughly about 340 kilonewtons per meter square. So this is the way we can solve this problem of partial pressure of gas constituents. So if you have any mixture of gas which has different constituents, so this is the way we can calculate the partial pressure of each constituents in the gas mixture. So this kind of problems are being asked in the jnth thermodynamics paper, which is in the second year, first semester. So thermodynamics subject, there is a chapter called partial pressures. It's a mixture of gases. So there the partial pressure problems are coming in the examination. Thank you.